So hello everyone, my name is Matthias. Today I'm going to talk about something a bit more special than anything you might have seen during this conference. We're going to talk about a pretty cool project we've been building in the StarkNet ecosystem, which is a StarkNet compatibility layer for Substrate. So if you know what Frontier is doing for the EVM, we're pretty much doing the same, but for the Cairo VM, which is like the VM that StarkNet is running on and that allows you to have provable programs. So let's dive into it. First, a bit about myself. I come from the FM world, so I've been working with MakerDAO for quite some time, mainly on StarkNet. Then I'm a core contributor to Madara, which we're going to dive into, and the co-founder of Pragma, which is an oracle that leverages Madara. So it's what we call a provable oracle, meaning that you don't have to trust anything about the data feeds you get. All the computation is proven, and it's just math. OK. So first, let's talk a bit about StarkNet. So I assume that most of you here are not familiar with StarkNet and the Cairo VM, especially, since we're going to focus on the Cairo VM. So this is like the architecture of a rollup, basically. So you have some mempool, you have a sequencer. The sequencer's role is to validate the transaction, to run the Cairo VM, and to produce block. A bit of context there, the Cairo, if you haven't heard about it, it's basically a Turing-complete language that allows you to generate provable programs. So like you write a for loop in Cairo, it generates a trace that you can send to a prover, which will then generate a proof for you, and you can verify that proof anywhere you want. So you have the sequencer, then you execute that, you send the block to the prover, and so the StarkNet OS then generates a state root and a proof, and then you can verify it here on L1, but in reality, you could verify it anywhere, even in the Polkadot relay chain, why not? So that's a bit like with the fractal scaling vision, basically being able to create rollups on demand. So let's dive a bit into how is that possible. How did we manage to incorporate this VM into Substrate? Maybe like a few words about why Substrate at first, since there are many solutions out there. So the StarkNet ecosystem is very Rust-focused. We are Rust lovers. Cairo has been rewritten from scratch to take some features from Rust, so traits, and all the things you love with Rust. And so everything, the VM is written in Rust, a lot of repos are in Rust, so it was like a very natural choice for us to leverage Substrate. And we love like all the features that Substrate come with, forkless upgrades, and all the things Polkadot people love. So, OK, it's a bit dark. OK, it's unreadable, right? So this is, we'll go through the flow of a transaction in Madara. So you have here some transactions, like I want to mint an NFT. Then in the middle, you have the Substrate node. So as you know, there is like the Substrate runtime and then the auto node. So in the auto node, you have the RPC, which we have rewritten from scratch, taking a lot of inspiration from the work done by Parity in Frontier. So the RPC is like fully compatible with all the StarkNet tooling. So in StarkNet, we have like our own tooling, have like StarkNet JS, StarkNet Rust. And so we needed to have this compatibility at the RPC layer, such that one could use a Madara chain without even knowing that's running on Substrate. Then you have the Substrate runtime, and we only have like one palette implemented. And the goal of this palette is to do three things. The first thing is decoding the transaction. So we receive a transaction from the RPC. We have to decode it to a format the VM can understand. Then we run a validate function. So this is a pretty cool feature with StarkNet, is account abstraction. Basically, what is very special with Madara and parachains builders will not really like about is that all extrinsics are unsigned. The root of all calls is none. So we haven't found yet a way to leverage Substrate in a way that comply with StarkNet account abstraction, meaning that in StarkNet there is no like external account. Everything is just a smart contract. And if you want to add some new validation scheme to, like, for instance, I want to use this curve for signatures verification or this curve, then you just write a smart contract that does this. So once you have run this validation, you execute the state transaction logic and you update the state in the database. OK, so once the transaction is processed, it's stored in a block. So here we use, again, the same technique as Frontier, so a technique that is called the block wrapper technique. Basically, the idea is that we have a 1-1 mapping between a Substrate block and a StarkNet block. One Substrate block is equal to one StarkNet block, and we have rules to prevent forking from like screwing up with this ordering. Once the block is generated, where you can just send these blocks to whatever proving service you want. So Sharp is the proving service maintained by Starkware, but you have probably in the future we'll have open source Stark provers and whatnot. And you generate a proof and you verify it wherever you want. OK. So this is the stack as it is. You could the idea is to have a very modular stack. You could technically change anything in the stack. The only thing that makes this interesting is like the execution engine, which is Cairo. And again, it allows you to have these provable programs. Then you have some settlement mechanism. As I said, we could imagine settling on the Polkadot relay chain. We just need some verification function for the proof. Then the sequencing. So for now, we're investigating different consensus mechanism to incorporate into Madara. So we have someone working on implementing Tendermint into Substrate, which hasn't been done before. At least we haven't found yet. If you have done it, please come and tell me. And yeah, so for now, we're like running with the basic Substrate consensus, Grandpa and Babe. But we could experiment. We have a team that looks into Narwhal and Bullshark as well. Yeah, it's very open. Then you have data availability. So if you're not familiar, it's basically, so you execute transactions, but you need to store this data somewhere such that if people want to restart the chain or like if there is a problem with the chain stops and everything, you want to have this data available somewhere in a secure way. Have a bunch of solutions, again, to do this. Celestia, Eigenlayer, even like on-chain, it's fine. And finally, governance. So we're actively looking into the governance palette of a Substrate to, because the cool thing that we chose to go with Substrate is we can leverage all the existing tooling that Substrates come with. And on-chain governance is a very cool thing, and I think one of the things Polkadot has done right compared to many ecosystems. Yeah, fork-less upgrades and on-chain governance is very important for us. OK, so we'll go a bit deeper into into Madara. The first thing, which I briefly talked about, is the block wrapper. So that was like the core of it. How can we? The end goal for us with Madara is to decentralize the sequencing layer of StarkNet to let people spin up app chains that run provable computation. And this block wrapper technique is like was very important for this. I encourage anyone to read about it in the Substrate core paper, I think. Then there is the custom RPC. So let's talk a bit about this, because usually with parachains, etc., you have the Polkadot RPC, which comes out of the box and have a lot of different endpoints to call the extrinsics of your palette. But here we cannot do this. We can use Polkadot.js to interact with our chain, but it might not be the best way since we have a lot of tooling dedicated to this built in the StarkNet ecosystem. So as I said, all extrinsic are unsigned with 0 weights. We haven't found a better solution yet, but we don't really care that much about signed extrinsics and weights, unfortunately. So we leverage a lot the runtime API to fetch information, and there are a lot of pretty cool techniques we've put in place in order for someone to get some info from the client side and without slowing down the chain, etc. So I think if you're building a chain based on Substrate, feel free to take a look. And finally, we have written extensive integration tests. So that was very important for us. We've witnessed that in the Polkadot ecosystem, there weren't that many integration tests. So what do I mean by integration test is spin up 3 nodes and run RPC calls through this with different libraries. Just check if the network is still in sync, if the blocks are being produced as it should. So we had to rewrite a lot of this logic. Frontier did a bit of work on this, but we extensively, I think, improved that whole end-to-end testing process. So here's a bit about a pretty cool thing we've put in place as well, leveraging artillery substrate. So this is artillery is just a way to send a bunch of requests to some off-chain service. And we leverage that to implement benchmarking in our CI. So at every commit in the GitHub repo, we see the average TPS that our chain can reach. And so right now the benchmarking is a bit false, but the idea is that we easily achieve more than 100 transactions per second, which is pretty good for decentralized sequencers. If you know a bit about the different metrics, it rarely goes above 10 TPS. So definitely Substrate has helped a lot with optimizing the performance of the network and everything, and we do not regret our choice for sure. So if you're building a chain again and want to add benchmarking in your CI, we also have average extrinsic per blocks and a lot of other cool metrics. Just take a look on the repo and you will find everything. Okay, so we talk a bit about everything that is done right now. Or everything I've talked about is running in production, where we'll have a public testnet pretty soon. But there is much more to do, especially on the infrastructure side of things. Basically, running some Docker scripts and Terraform to just let anyone spin up nodes very, very easily. And then a lot of research as well. So as I said, we're actively looking into entanglement into Substrate. We think Grandpa and Aura it's a pretty good protocol, but Tendermint has also a lot of great advantages, and all the BFT consensus schemes are somehow interesting for us. Then there is staking. So we're trying to leverage the proof of stake mechanism that Substrate has natively. But the thing is that with rollups, the staking happens on the layer under. So if you're a layer 2, the staking, you have to interact with the layer 1. If you're a layer 3, with the layer 2. And so we have to tweak a bit the Substrate proof of stake mechanism to work in that situation. Same for data availability schemes. That's a lot tweaking into Substrate. And just to note, we haven't forked Substrate. We're just using it as is. And it's very important for us to not fork away from Substrate, to have the benefit of all the production work and the experience that the Polkadot community has. Integration of proving as well. So right now the sequencer is running in a decentralized fashion in a very good way, but proving is not integrated. So it's good you're running provable transaction, but you're not actually proving them. It's a bit of a shame, and we're actively working onto it. You have a lot more to do, and that's what made us choose Substrate at first. It was really like the flexibility that Substrates come with. Everything is generic. It doesn't make any assumption about the storage layout and all these kind of things. For instance, for our case, for the Oracle, we're looking to change the storage layout into something like very optimized for Snark proofs. Same for hashing function. We have implemented Poseidon, which is like a very Snark-friendly hashing function, and that will, again, help us optimize our use case. And the last thing is optimization. The benchmarks currently are pretty satisfying, but we believe that given the fact that we don't have an extensive experience with Substrate, there are a bunch of things we can optimize, and I highly encourage anyone here that has definitely more experience than us with Substrate to come and contribute to the repo. Everything is open source. Everything is, yeah, we have a very vibrant community. You will find a lot of, you'll be able to talk with people and everything. And we have some people from Parity that came and are starting to talk with us and contribute to Madara. So yeah, I will put again the QR code here. Yeah, and I think that's pretty much it for me. We could talk for hours, but I think the best that you come and discuss with us, and if you have any ideas about any part of the stack, would be very interesting to have you contribute. Thank you very much. Are there any questions? Yeah.
How do you address MEV, or you plan to?
Yep, so that's a pretty good question. So that wasn't a problem yet on StarkNet, since the sequencer was centralized. And of course, as soon as we decentralize the sequencer, we start encountering some MEV problems. So there are a few different solutions. One I quite like personally is having an encrypted mempool. And I think that the Mangata finance team has already done some work on that previously with Substrate. So that would be a solution, encrypting the mempool so that people just cannot see what's happening. There are other solutions like trying to find some integration with flashbots and everything, or talk with, so yeah, I'm not like an MEV expert, to be fair. Personally, I really like the encrypted mempool solution, but if you have any idea, feel free to come and chat. Yeah.
Hi. So what would the benefits of Tendermint on Substrate be for you? I sort of didn't catch that.
So it's just for our specific use case. So StarkNet has done a lot of research in like how to decentralize the consensus and everything. And Tendermint is pretty good since it cannot have any reorgs, and like BFT protocols in general cannot be reorged. That's a very cool property to have, especially in the landscape of rollups where one reorg could have an impact to all the layers above, and definitely not something you want to happen. Then just the deterministic aspect of Tendermint as well, the fact that you have, the rounds are very deterministic instead of a more probabilistic consensus. Yeah, but for now we're quite happy with Grandpa and Babe as is. But it's just for a matter of exploring, and it's a stack again. So anyone, if you have a specific use case, you might need a different consensus just because your use case requires them. Like if you require very, very fast updates, maybe Nawal and Bullshard consensus types are more interesting for you. So that's why we're trying to have a bunch of different solutions available in the stack so that you as a app chain developer can just come and pick up whatever solution you like.
We actually have Tendermint on Substrate, so
Oh, you have?
we should speak after.
So okay, great.
Hello, thank you for your presentation. You using a lot of different kind of stuff like Tendermint, Substrate, EVM, Solidity, so that's very cool. What do you think in the future more and more developer teams want to using Substrate for scaling on Ethereum?
Yeah, so this is kind of what we basically do. So it's Madara is at first meant to. So if you take back the flow of a transaction, at the end you have generated this block on your Substrate chain, and you can send this block to any proving service. And that's like the whole goal of Madara is that it's provable, really. Like all the transactions generate some trace, and it's provable. So you can just by running some verification algorithm, and you can do that on any chain. If you do that on Ethereum, then you're scaling Ethereum because you're like a layer 2. If you're settling on a layer 2, you're layer 3. If you're doing that on Bitcoin, you're layer 2 on Bitcoin, or whatever. I don't think it's possible on Bitcoin, but there are people trying to do it in Madara as well. But yeah, so in the end, yes, to answer your question, you can scale Ethereum just by doing exactly what is written here. So you send to Shard, which is like the Starkware ZK prover, and then you verify it on Ethereum L1.
Okay, thank you so much.
You're welcome. Okay, thank you very much.